Hey, how about a tip video today? Let's get to it. Alright, I've seen an issue come up a lot in comments, and the issue is basically uneven heating and cooling from the HVAC system. And what I'm talking about on uneven cooling is hot on one side and cold on the other. And it doesn't matter which one is which. It could be hot on that side and cold on this, or vice versa. But that's what we're going to talk about today. I'm trying to give you some tips or things that I think about when I'm dealing with this. Now, there are three things I try to think about or keep in the back of my head at least when it comes to dealing with uneven hot and cold situations like we're talking about today. The first thing is it an AC refrigerant issue? Basically low refrigerant, moisture or air in the lines, a restriction. Any of those things could cause an uneven, heating cooling situation. At least you would perceive it that way. So you got to that's the first thing I kind of keep in my head. The second thing would be a coolant or antifreeze issue. Basically low coolant or air in the cooling system or a restriction in the cooling system. Any of those things could cause a problem, similar to what we're talking about today. Or the last thing we'll talk about is a blend door issue. Now typically you're only going to see that on dual climate control systems like this vehicle right here. And that just means we can have one temperature on the driver's side and we can have a different temperature on the passenger side. Many modern cars are going to have dual climate systems like that. Now, when I think about those three things when I'm dealing with the problem, I try to think about it logically. Now, if it's summertime and the complaint is when I'm running the AC, it's blowing cool on one side and blowing a little warmer on the other, I'm typically at least going to look towards a possible refrigerant issue just, because of my experience and because, we're dealing with summertime and AC. I'm going to look towards an AC problem first. Now, it might not be the case, but at least I'm going to be thinking about that probably more than other things. In the case of Honda, a low refrigerant issue, just the way it's plumbed, the way the refrigerant comes in on the passenger side and runs through our evaporative core, it's going to cool this side first, and then it's going to cool this side second, just the way the refrigerant travels. So if it's low on refrigerant, and I did a video on this before, by the time the refrigerant gets over to the driver's side, it will have lost its capacity to, exchange that heat. And so you're going to feel warmer air over here than over here. So that's why, just the way, if I see heat over here and cool over here in a Honda, I'm looking towards a refrigerant issue. Now, other vehicles, that might not be the case, just depending on how their AC is plumbed. So you always have to kind of know what vehicle you're working on and what the problem is, what time of year it is, what's going on. You definitely want to get the whole complaint. It can't just be, hey, there's hot air on one side and cold on the other. That's, that does not narrow it down, at least to try to fix it. We need more details. If it's wintertime and the complaint is no heat on one side, but there's plenty of heat on the other side, then I'm going to at least verify that our coolant level is correct, that the whole cooling system looks good, we don't have air in the system, especially, hey, did we just work on the cooling system? Did I just drain the coolant and refill it? Maybe there's a big air pocket in there and that's what's causing our issue. So once again, trying to think logically, to fix the problem. But of course, one of the most common issues that can happen, to divide the air and get hot on one side and cold on the other is a problem with the blend door or air mix door, depending on, what manufacturer it is. And basically, the blend door actuator, its job is to move a door inside our HVAC unit, and we're just going to blend the hot and cold air, to get our desired temperature. So it's pretty simple. And of course, like I said before, we need to know if we're working on a dual climate system or not. Older systems, they're going to have a single climate control. So basically, you just pick one temperature and it's going to come out all the vents. So that means there's only going to be one set of blend doors inside there. Typically, there's more than just one. There's usually a couple of them. But for simple terms, we'll just talk about one blend door. But on dual climate control systems like this one, you can see we can control the passenger side temperature right here, and so that means our blend doors are going to be split right down the middle. So when we change the temperature over here, our blend doors are going to move inside there and they're going to change the temperature on that side, and vice versa, when we move the temperature over here, it's going to move the blend doors but only on this side over here. So definitely helps to know, do I have a single climate control system or do I have a dual zone? Alright, the complaint on this vehicle when it was brought in was that it was blowing hot air all the time on the passenger side. So it didn't matter what temperature you selected, you know, from the controls right there, it always blew hot air. And it didn't matter if you picked vent or defrost or floor, it was all the same, hot air all the time. And I already diagnosed the problem, and actually it's already fixed. And the problem was the blend door actuator, which on this vehicle lives right up there. So for the purposes of this video, we're going to concentrate on issues with blend door actuators and blend doors. We'll stick to that for this video, and we'll save AC refrigerant issues or low coolant issues. We'll save those for another time. Alright, to give us a better representation of these HVAC systems, I have this little sample setup right here. Now this happens to be for a Honda, but it's a pretty typical setup, so it'll work well for a demonstration. Just to get orientated, this would be the front of the vehicle, this would be the rear, and then right about here would be the middle of the vehicle. So this will be the driver's side, this will be the passenger side right here. So down here we have our blower motor. Right here behind this cover would be our cabin air filter. Up here would be our recirculation door. So it's kind of a shroud that goes up and down like that. So in the position that it is right here, it would be pulling in fresh air, and then when this recirculation control motor, which lives right here, moves the door, it'll move up like that, and then it'll be pulling in recirculation air. I can show you this on our demo vehicle, which happens to be a Lincoln, but it's a very similar setup. So we can definitely see that in action. And like I said, our recirculation motor kind of lives right here. You can't really see it. That's a picture of on this demonstration what one looks like. Right here would be the mode control motor, and a lot of these, this one just has probably one rod, but some of these have multiple rods because usually there's a couple doors that they're moving. So whenever you disconnect them, you might have one or two rods you have to disconnect also. But on our mode control motor, it's going to change whether the air comes out, you know, up here on the defrost or right here in the vent. So that would be representative of the 4 vents coming right at you, or going down to the floor. So pretty simple. It's just going to move the air back and forth, or a combination of them. And then we get over to our air mix motors. That's what Honda calls them, or otherwise known as blend doors. A lot of manufacturers just simply call them blend doors. And that, like I said before, it's going to blend the air, the hot and the cold air together. Now in a dual climate system like this one, on this demonstration vehicle, or model here, we're going to have a driver's air mix motor or blend door motor, and it's going to be over here, and then we're going to have a passenger one, and it's going to be located on this side. And that just separates our system kind of right down the middle, so we can control the temperature on this side, and we can control the temperature on this side. Now I should mention, you know, for most systems, the air is going to kind of come in this way from the blower force of the blower motor, and then it's going to go this way, and then it's either going to go out, you know, the vents or up here, or down through the floor, or any combination, but the air is kind of going that way. Right here we have another look at kind of the same thing, only we've turned it and we're kind of looking down the driver's side. So we're going to be looking this way. That's how we're situated right here, so we can kind of get a look at how the doors are working inside of a typical unit. So here's our airflow coming at us right here, as represented by this color stream right here. That would be ambient air. And in this demonstration, we're going to have it on cool, like we have the AC on. And so our air is going to come down through us, or down this corridor right at us, and then it's going to go across our AC evaporator core, and that's going to cool it off, or it's going to exchange heat. But for the simple purposes, we'll say cool it off. And then it's going to go out cool. That's represented by the blue here. And it's going to go, in this case, we're going out the vent, so this would be our defrost, this would be the vents, and this would be floor. So the air is coming out the vent, and it's coming out the floor, and it's coming out cool. That's how we have it on this situation. And right here and right here, those are going to be our air mix or blend doors right here. So that's what we're going to be concerned with. These 3 doors right here would be our mode doors, and they're the ones that are going to kind of change the airflow, you know, through the, you know, whether we want to go floor, vent, or up to the defrost. And then these are going to change it between cold and hot. So we got to remember that this right here is our heater core, and as we can see by this demonstration, our air is going around the heater core and going out, so it's staying cool. Now I'll show you another representation, this drawing over here, where we're going to turn the dial all the way to hot and see how this changes. Alright, so on this one we've turned our dial all the way to hot, so we want hot air coming out, and we've changed our mode to come out the defrost and the floor only, so we've cut off the vents. So you can see how our mode doors have moved from the positions that they were right here. You can see how they're changed over here, and we're blocking the vent off, and now we have the air coming out that way. So if we follow our airflow, here's our ambient air coming in. We're going up across our AC evaporator, and then now we've changed our blend door right here from this position here. We've changed it to this position, so now the air is coming across our heater core, and now it's being heated. Well, as long as the vehicle's been warmed up, and we have the proper amount of coolant and everything in there, no air in there. So as long as the system is working properly, we have our airflow coming across the heater core, and now it's heated up, and now it's coming out the appropriate vents whichever way we want them. In this case, like I said, we have it coming out the defrost and the floor. So that's a typical setup, and that's a typical way that these blend doors, and we got a good shot of the mode doors, how they change everything and how everything's working. Most modern systems kind of run this way, where we run the air across the AC and then we run it across the heater, and then we just change the value on this door, whether it be like this or like this or like this, and that can blend. Now of course, these two situations we're looking at here, this is fully cold and this is fully hot. If we just change it a little bit, we can mix it and kind of have warm air. So that's how it works, kind of in a nutshell. Not too complicated, but in case you've never seen, kind of the inside workings, that's how it works. Alright, back to our problem vehicle. I pulled the glove compartment out so we can have access. But there's our blend door actuator right here for the passenger side, and the electrical connector is right down where you can't see it, right by the tip of my finger. You can see the little arms coming off, plus a little rod, and that's going to move our doors like that. Right down here would be our blower motor on this vehicle. Behind here is our cabin air filter, and you can see it right there. And then behind this little screen here, that's where the recirculation door opens and closes. I'll see if we can get a shot of that in action in just a second. Alright, I have the HVAC system on. Now I'm going to hit the recirculation button and we'll watch the door move. I just hit it. And there we go. So now we'll be pulling in fresh air from outside. If I hit it again, now it should move back, and now it'll be pulling air for recirculation. It'll be pulling air from inside. So with the HVAC controls, it's kind of nice. You can move actuators just like you could on a scan tool, but we can do it right from our climate control unit, because I can control all these with a scan tool also. And so that's what I did with our blend door motor or actuator here. I just changed the temperature, so I'm gonna change it again. It was on cool, we're gonna go to hot, and we'll watch for movement on that door. And there we go, it just moved right there. And that's a good, quick, easy way to verify that everything's working. So we know that our controls are working, our buttons are working, and our motor, actuator, everything, the linkage doesn't seem to be binding, everything is working. That's how it's supposed to work. When I did it before, what happened was I would change the temperatures. I tried it on here, and I tried it on a scan tool, and it didn't matter, nothing would move. And then I did my old tap test. I tried tapping on it, nothing changed. And then, I was kind of worried that maybe we have a broken wire or something, so I unplugged it, and then I commanded it with the scan tool, and of course it didn't move. But what I was trying to do is see if we could set a trouble code, because I scanned the system and there were no codes. So even though this system is capable of generating codes, it didn't for this issue. So once I unplugged it and tried to move it, then I rechecked it for codes, and of course it set a trouble code saying that the position was wrong. So that's a kind of a quick and dirty way to kind of verify your wiring integrity. It's not foolproof, but it's an easy way to kind of give direction. Do I have a wiring control problem, or is it more likely a problem with the motor here? And so that kind of verified that my problem is probably up here. And when I plugged it back in, as the moment that I plugged it back in, as soon as the little metal contacts made contact with each other, the motor moved and it went right to the position it was commanded to. So our problem on this vehicle was the contacts at the connection to our motor were, not very good, and just unplugging it, plugging it back in fixed our problem. So no parts required. But that's always something to be aware of. Don't just wing parts at it. We kind of want to see if we can do a few tests to narrow things down before we start firing parts and spending money. Alright, I hooked up the scan tool. I'm going to show you what it looks like on the scan tool also. So we're just going to go into our HVAC module and do some active tests. And in this case, we're working with the right blend door, and it's always right or left is always with you sitting in the vehicle. So if we're sitting in the vehicle on the right side or passenger side, that's going to be our blend door position that we're going to be looking at. And where's our right blend door position? Right there. We're going to select that. And you can see we're at 100%. That basically means all the way to heat whenever we see 100%. So we'll come down here, and what we'll do is we're going to decrease it, and we're going to watch it move. So I'm just going to decrease it. It's at 90%, 80%, 70 now. And it's usually delayed. It takes a second before it starts moving. 60. And I'll just keep going all the way down to 0. Now we're at 30%. You can see now we're at 20%. You can see with the glare. We'll decrease it down to 0. There we're at 10. And there's 0 right there. So if we look at our scan tool, we can see right door position 0%. And that's the position it's in at 0. And so that's an easy way to check, if you have a scan tool. Of course, we could do the same thing there, but you got to remember it's sensing a temperature change. So there's a lot more of a delay when you're working with this. So that it helps to actually look at the blend door position on here, because there's also a live data PID where we can look at the blend door position without commanding it. And so it's a good idea, if you have access to a scan tool, you look at it so we can see if there's changes on there. And I noticed that it was changing, from 0 to 100 whenever I was changing the temperature on there, but yet nothing was moving. So the feedback circuit that's in there is not exactly perfect, because without it moving, it should have set a trouble code and it didn't. But I just wanted to kind of give you an idea what you can do with a scan tool. You can look at things like that and command them, see what position that the HVAC controller is seeing and what it thinks it is, and so you can kind of compare and see what's going on. And like I was saying, if we go to live data, we should be able to see our blend door positions right on here, not only the left but the right. You can see there's quite a bit of data on this HVAC system, definitely more than you get on Hondas. I'm used to not being able to get much on a Honda. So we have our right door position, and where's the left? Did I miss it? There's our left door position. Now we haven't messed with that, but we can look at them both right there. And so they're both at 100%. And so if we turn it on, yeah, they're both at 81 degrees. So if we change, now I have it set so that if I control it on the driver's side, it'll change both. So we go down to low, and there we can see both blend doors show 0%. Hopefully you can see that. And so with the scan tool, we can see what the HVAC controller is seeing, and then of course we want to visually look. And so what I did is I just went onto the driver's side, I changed the controls and looked for it to move, and the driver's side moved no problem. When I came over here and looked, I did the same thing, tried to move it, and then nothing moved. So I knew our problem was definitely over here in this thing, because it should have been moving. If this was moving no problem, then we might have to look at something else. But in this case, this was the issue, and it was simply a contact issue. I think that it's going to be fixed. I don't want to delve into it any further. It looks like the actual pins in there, the pin fitment is okay. So typically when something like this is working, I don't want to mess with it any further, because it's hard to diagnose something or fix something when it's working. I like to fix stuff when it's broke. So in this case, we're going to leave it like it is, and if it comes back, then we'll have to move on to it further. But I just believe that, you know, over time, especially this vehicle lived in the rust belt for quite a while, pin contacts get bad, and just taking it off, putting it back on, they make good contact, and it could go like this for years before having any issues. Now, if the actuator on this vehicle didn't start working, we'd have to check it electrically. Now I pulled up some wire diagrams. This is going to be for a Honda. This is going to be for our Lincoln that we're working on. So over here, Honda's calling it front passenger air mix control motor. Over here, Ford calls it right hand temperature blend door actuator. I actually like this name better. That's pretty clear cut of what it is. But most of these are going to be 5-wire systems, just like this. The Honda's no different, 5 wires. They're just going to label them differently. Over here is kind of clear of what everything is. We have our motor here, and then we have our sensor that senses the position of the actual motor or linkage where it's at. So these 2 wires are going to power the motor itself. So we need power on one, ground on the other. Now, because the motor goes back and forth, sometimes this will be power and this will be ground, and then sometimes it'll be vice versa to make the motor run the other way. But in either case, we're looking for power and ground, or battery voltage, you know, and ground on these 2 wires right here. And then the other 3 wires are going to be a 5-volt reference. So 5 volts is coming in from the one of the controllers is sending 5 volts in. And then we have a signal ground for this, or signal return, as a lot of companies call it. And then we actually have our signal. In this case, Ford calls it a feedback. Over here for Honda, we have, you know, these 2 go to our motor. So this one, they're saying M cool and M hot. So basically, we'd have power on this and ground to make it hot, and then power on this and ground over here to make it cool. But in either case, same thing. We're looking for power and ground right there. And then here's our 5-volt reference coming in. Here's our sensor ground, or signal return. And then this is our actual signal. And what do they call it? Honda calls it potential. So you can see right there, they're calling it potential. They call it feedback, but in either case, it's a signal that the HVAC controller is looking at, just to tell it where the position is. Typically, these signals are going to be between 0.5 volts and 4.5 volts. So between roughly 1 to 4 volts, give or take a little bit. That's what these things are. You know, they're changing the voltage. They're changing this 5 voltage, or 5 volts that's coming in when the you know, potentiometer or whatever they have inside there, when it's moving, it's just changing the resistance, which changes the voltage that's going back. And we're looking anywhere from, you know, we want to see 0.5 volt to 4.5 volts. We don't want to see 0, and we don't want to see 5. It's typically going to be more than 0 and less than 5 on a good working system. Alright, so in this case, as we saw, unplugging it and plugging it back in fixed it, and it was our blend door actuator down there, or the electrical connectors at that blend door actuator motor. But a lot of times when you are controlling things, of course, when I was looking at it and manipulating it, and I could see that it wasn't moving. But a lot of times, without even taking anything apart, you can move the controls and listen very, you know, closely, and you can hear the doors and actuators moving back and forth. Especially, you know, with the vehicle off, you know, shut the garage door or something, make everything quiet so you can hear it. A lot of times you can hear them move back and forth, and if that's the case, then that may steer you to another issue. So we always, of course, just want to think logically about when we're, you know, trying to fix these things, because just because it's hot on one side and cold on the other doesn't mean it's always a blend door issue, or always a refrigeration issue, or always a coolant issue. It could be any combination of the 3, and heck, in some cases it could be more than one problem. We've seen that before. So these are all things to kind of think about whenever we're diagnosing something like this. All right, let's test this thing out. Change that temperature, put it all the way to high. The vehicle's warmed up, by the way, so you can see we're getting hot. Went from 70 to over 100 now. This one's staying the same. I suppose we could check that one out too. Let's see. We'll turn it up. All the way to high, see what it does. Looks like it's working too. We'll put them back down. This is where I sure like a dial. Guess I'm old. I hate pressing buttons 50 times when I could just turn a dial and be done. Going down, not quite as fast as it went up. That's to be expected. We'll do the same thing on this side because it was still pretty hot, 164 degrees. That would suck if it was stuck there and you're just sitting in the passenger seat with 164 blowing on you and it's like 85 or 90 degrees out. So it's going down also. I think we got a confirmed fix. Both sides seems to be working. Well, there you go. Hopefully you know a little bit more about these HVAC blend door systems now that you watched this video. I wish I could have tested electrically, but I would have had to take some interior plastic parts off, and I take a chance on breaking them. I don't own this vehicle, so I don't want to pay for any broken plastic parts if I don't have to, so we're going to leave it alone. But hey, as always, if the video helped you out or you liked it, make sure to give it a thumbs up. Thanks for watching.